This is an explanation of how I'm driving two finger joints with a single motor. Here would be the servo motor. This pink portion is the hand, and this orange section is the first finger section, and the purple part is the fingertip portion of the finger. The first section of the finger is joined to the hand at the first knuckle here, which is this yellow dot, and it's joined to the second finger section at this joint, which is the knuckle. The green strut is only connected to the hand, and it's connected here at a pivot on the hand and to the fingertip portion of the finger. It's not connected to the first section of the finger. It's just connected here to the first fingertip. And it's a strut that is rotating around this point, so it is forced to path on this green path at all times. And likewise, the first finger section is rotating around the first knuckle. So this part of the first finger section is following this red path, and it always follows that red path. The blue strut pulls on the first finger section to make it rotate around this point, and this horn on the servo motor pulls the blue strut in that direction. So up in the second picture we have this blue strut has pulled the first section of the finger up a bit onto an angle, rotating around this point, and the green strut has started to rotate, and it's still on its green path. And because the other knuckle is getting closer to this point of the green anchor, the purple part of the finger has started to rotate. And we can see in the third picture, so the servo motor has rotated even further, making the first finger joint or first finger section rotate further. And now this point on the first finger section is closer to the green strut pivot point than the point where this green strut is connected to the fingertip section. So now it's actually rotated even further. So this arrangement has a couple of problems that arise. For example, we can see here that the green strut is interfering with the blue strut. It's actually occupying the same location, and it can't be allowed to do that. It will break something. So they can't be in the same plane. It'd have to be in a different plane. But it's even more complicated than that, because the first finger section actually starts to hit this pivot point for the green strut, and that has to be avoided as well. So they can't be in the same plane, or the pivot pin has to go through both the hand and the strut, so it may be interfering. And when this goes even further, the other pivot point actually intersects with this green strut, and that has to be avoided. So it's not easy. It's pretty tricky in 3 dimensions to make sure that there is no interference between these struts and all these pivot points. So that provides some idea of how the finger mechanism works. and some of the issues that you run into when you try to do this. Now, when I was first designing this, I really just visualized all this mechanism in my head and tried to work out how it would work and how it would fit together and how I would avoid all these issues. One issue I ran into that I didn't initially visualize is that all the motors in the hand start to interfere with some of those blue struts, and that has to be resolved. Even with all the visualization, there were still lots of issues that had to be resolved at detailed design time. I went through 3 iterations of test pieces before I got the geometry right. And then I went through a couple more iterations just to get all the clearances and interferences fixed up. So visualization was very important, crucial in fact, but detailed design and prototyping and testing were absolutely necessary. However, I did end up with a working proof of concept prototype, and I'm pretty happy with that.